In this video, we're going to talk about how to determine the magnitude of the sum of two vectors, as well as how to determine the direction of the resultant vector when you add two vectors geometrically. A vector is a line segment with an arrow that has a direction and a magnitude. Geometrically, the magnitude of a vector is the length of a line segment. It's always positive. The direction of a vector can be either positive or negative. In order to add two vectors, put them in tip-to-tail order and connect the origin and the final point, the end point, with another vector. That vector is the resultant vector. The direction of the resultant vector is determined by the angle formed at the origin between the initial vector and the resultant vector. Let's see how we can determine the sum of two vectors, how we can establish the magnitude of the resultant vector given the magnitudes of the two vectors, and how we can find the direction of the resultant vector given the angle between the two vectors. So here we're given the magnitude of vector A, which is 4 units, the magnitude of vector B, which is 7 units, and we need to find the magnitude of the sum of the two vectors and the direction of the new vector, A plus B. Before we do anything, we need to create a diagram to kind of establish what the resultant looks like and how we can proceed with our calculations in order to determine its magnitude and then the angle. So let's look at the diagram. So we can translate vector B here so that the vectors are arranged in a tip-to-tail order. Then the vector that connects the origin and the end of vector B is going to be our resultant vector. So this is A plus B. You can see here that it has formed a triangle. And in that triangle, we're trying to determine the base, right? We know the two sides, and it would help us if we knew this angle here in order to be able to use the cosine law, since we have two sides and a contained angle, to find the opposite side. In order for us to determine the measure of that angle, we can create a parallelogram, complete this whole diagram here. And in parallelogram, opposite angles are equal, so this angle here will be 60 degrees. Then these two angles together will add up to 240 degrees, and since the opposite angles are equal, each one of these angles is 120 degrees. Let's now recreate this triangle here. So we have our triangle. This vector has a magnitude of 4. This vector has a magnitude of 7. And we have the angle between them of 120 here. And then we're trying to find A plus B, which is the opposite side. So again, we have a contained angle and two sides. We can use cosine law. So A plus B, and since we are determining the magnitude, we're going to square this and put into absolute value brackets, since magnitude is always positive, is equal to magnitude of 4 squared plus magnitude of 7 squared minus 2 times 4 times 7 times cosine of 120 degrees. Let's evaluate this. Equals 16 plus 49 minus This will give me a negative value, negative 28, so plus 28. A plus B squared is equal to 93. Therefore, A plus B is equal to square root of 93, which is equal to then 9.64 units approximately. So we have determined the magnitude of the side, A plus B. Now we need to determine the angle right here, this theta, this portion of the 60-degree angle where the resultant vector connects to the original vector. This will give us the direction at which A plus B is going. Now that we have determined the magnitude of A plus B, we can determine the direction. So the magnitude of A is 4, the magnitude of B is 7, the magnitude of A plus B is 9.64, and we have an angle of 120 degrees at the top. We can determine angle theta by using sine law. Theta is the angle at which the A plus B vector goes in relation to vector A. So the pair that we've set up first will be sine of 120 degrees over 9.64 equals sine of theta over 7. Cross multiply, so this times this, divided by 9.64. So then we get sine theta is equal to 7 times sine 120 degrees over 9.64. Theta from here equals sine inverse of the value that you get when evaluating this number. So theta equals approximately 39 degrees. So therefore, the magnitude of the sum of vectors A and B is 9.64 units, and it's going, the vector is going in the direction of 39 degrees from A towards B.